So what we'll cover today, I'll give you a brief overview of ABEC, who we are, our philosophy, looking at, future industry challenges and trends. Then we'll take a look at, different types of facility designs, a typical stainless steel facility, a hybrid, and a single use. And then we'll take a look at some actual examples or case studies of future facilities that ABEC has been involved with the design and manufacture of. And then we'll take some time for some Q&A. So, brief introduction on ABEC. The company's been around for 49 years in the biopharmaceutical field. We focus really on clinical and commercial scale manufacturing. We have a very vertically integrated company, so we have many engineers, both electrical, mechanical, process engineering. We have designers, and we also handle all of our manufacturing in-house. What we really like to look at is integrating bioprocess equipment and engineering. So that's the full facility, whether it's new technology that we're bringing in to developing the controls for, or integrating it into existing facilities, new designs. And we really like to take a holistic approach, looking at the upstream equipment, the downstream, and any supporting utilities or preparation skids. We also are a very agnostic company. We have both stainless steel and single-use capabilities in-house. So we really like to look at the needs of the customer and determine together what the best facility is, rather than push one versus the other. A little history. So company was founded in 1974 by Jack Wilson. He's actually the not the patent holder, but the inventor of the low shear elephant ear impeller, which you all might be familiar with from bioreactor cultures. He actually didn't patent it because he wanted to further, knowledge within the industry, and that type of mindset is really, held true for ABEC throughout the years. You can see a history of some of our, first dual-purpose microbial skids, first automated production facility. You'll see in the beginning of the 2010s, we launched our single-use product line, expanded our manufacturing facilities, and now have really started pushing the envelope on the large-scale single-use side of things. I'll get into it a little bit later, but that really has some really intriguing cost of goods advantages. So if we take a look at the industry today and trends that look like they're going to continue forward and what's really shaping facility design now. So as all of you I'm sure are aware, we're getting higher titers in the cultures. This is kind of happening two ways. We're getting much higher cell densities, whether that's through perfusion type systems or fed batch mode with just really chemically defined medias that are allowing these cells to grow at much higher densities than we've seen in the past. We're also just seeing much more efficient cell lines. We've got a lot better equipment on the research and development side to allow our scientists to select the best cell lines for a given product. So that's leading again to those much higher titers in the culture. This has a lot of knock-on effects, both for the upstream equipment as well as the downstream equipment that we'll take a look at. We're also seeing a push for multi-product facilities. This is kind of driven by bullet point number 3 in some ways, which is the personalized medicine or the cell and gene therapy side of things. It's also just following with how many drugs are coming down the pipeline lately. A lot of companies, because they're running some smaller batch sizes or much more efficient batch sizes, are going to want to be able to run different products through the same facility. That way you're maintaining full utilization of the plant. So reiterating what I touched on a little bit, all those industry trends are leading to the smaller batch sizes. Also, there's a push for quick cycle times in some cases. That could be on the seed reactors, that could be on the production fermenters or bioreactors. There's also a want in the industry for an ease of cleanability as well as documentation. Long SIP and CIP cycles, especially when you're talking about that product-to-product changeover rather than just batch to batch. If there's any quality people on the line, I'm sure you can appreciate that more than I can even. One thing that we also need to keep in mind is that these higher densities in a lot of cases are leading to much higher performance demands in the equipment. Much higher mass transfer, potentially, blend time sensitivity. We also need to watch out as we're trying to push the, oxygen transfer side of things, that we still maintain a good environment for the cells, looking at CFD analysis, shear sensitivity of the agitators. So there's a lot that goes into just the equipment side of design, even before you really start looking at the full facility as a whole. So looking at some common uses of single-use and stainless steel equipment, there's obviously a lot of overlap between the two, because the industry, really everyone pretty much has started in stainless steel at some point, stainless steel or glass. And then as you're moving through your seed reactors or into your production, maybe you start looking at the single-use side of things. So, one of the classics, monoclonal antibodies, whether that's CHO or a different type of cell line, you'll see used, stainless steel bioreactors, frequently other stainless steel process equipment such as centrifuges or chromatography columns. In recent days, single-use bioreactors have really been taking over in that market, again, because of those higher titers. There's also been, a push for some supporting single-use equipment as well, whether that's downstream pool tanks, some single-use TFF systems. There's also at the kind of small to mid-range scale, some single-use centrifuges and chromatography columns available. Recombinant proteins, really used across the board on the equipment. If we're looking more at the DNA side of things, viral vectors, now we're really starting to look at the single-use side because of those smaller batch sizes, kind of more personalized type medicine. Sorry, I gotta move my view box here for a little bit. Plasmid DNA, that's going to be a typical fermentation operation, typically done in stainless steel. But there are now single-use fermenters that are capable of handling the same process loads that customers were used to doing, and the same performance that they were used to getting in stainless steel. For the longest time, single-use reactors, because of the way they were designed, were really focused on just supporting bioreactor culture, especially the power input on some of the agitation designs, specifically looking at like mag mixers. You really end up limited on how much power you can get into the system. And then, finally, we're looking at reagents, diagnostics. There's also some animal vaccines being used across the industry. So we took, there was a sample of 117 CDMOs. This was focused on fermentation and what equipment they used. So you see there is a split between stainless steel fermenters, single-use fermenters, especially on the fermentation side, still leaning towards stainless steel, again, for the performance impact. And then, the other column includes all kinds of small scale supporting equipment, such as wave bioreactors. So just a quick peek to show that, the industry is definitely split between stainless steel and single use, but, stainless steel is not going anywhere. There's still a use case for it, as I'll, bring to light throughout the presentation here. So if we look at the single use side, stainless steel, I think everyone should be familiar at this point at the availability, but it's pretty much all the equipment you could need in bioprocessing is available in stainless steel in one way, shape, or form. So taking a little bit closer look at what's available on the single use side, kind of the newer technology, just in the last decade or two here. And what we'll see, on the standardized systems, on the off-the-shelf, you can really get discrete volumes up to 2,000 liters for the bioreactors, and then for the fermenters, again, because of that kind of power issue and performance issue, you really only get up to about 300 liters. The mixers and solutions prep, we can go up to 5,000 liters, and there's solution hold systems out there, the stackable 1,000-liter totes, up to about 3,000 liters. There's also a couple different filtration, TFF, and hollow fiber systems available. If you look at, kind of the customized side of things and the really large scale single use. ABEC offers a 6,000 liter bioreactor, a 1,000 liter fermenter, and then the supporting equipment to help with those large production volume scales. 7,000 liter mixer harvest or solutions prep system, a 4,000 liter solutions hold system that we'll take a look at that really helps to cut down on footprint usage within the clean room facility. And finally, large scale TFF at 40 square meters. And I'd mentioned it before, but there are also, single use chromatography and centrifuge systems. To date, those are really more for the small to mid scale. We're still waiting on some really large scale centrifuges to be used. So if you're looking at building a new facility, there's a couple different options you could go with as far as your kind of production reactors. You can look at kind of that standard off the shelf, about 2,000 liters. There's a couple companies out there that do that. The pros of that are, very low capital cost when you're setting up a facility, and you get this single-use multi-product flexibility that I touched on earlier. Some of the cons of going at that 2,000 liter scale, you do have higher cost of goods sold, which is really important when you're looking at facility design to make sure you have a business case. There's a limited process performance in a lot of cases, especially if you're looking at any kind of fermentation or really high density bioreactor type applications. We have, sorry. A lot of them have inflexible supply chains. Swapping in and out parts is pretty difficult when you're buying off of kind of a standard catalog approach. And a lot of their designs are different than your typical stainless steel reactors. So you're going to have trouble and get poor scalability or performance when you try to go past that 2,000 liter scale in a lot of cases. If you look at the customizable single-use approach, up to 6,000 liters, you get that same single-use multi-product flexibility. You get some of the lowest single-use cost of goods, and you also get the best single-use performance because the equipment is customized to your process rather than trying to customize your process to the equipment that you have, which can lead to some inefficiencies, some lost product, which again, as we're seeing at the industry trends, we're trying to get those titers as high as we can go, those densities as high as they can go. So why not provide the cells, with the best equipment, the best culture conditions that they can have. The cons of this is, there is a medium capital cost is going to be higher than those catalog items, but still much cheaper than the stainless steel bioreactor facilities that were the norm in the industry for the longest time. So looking at that, stainless steel bioreactors up to, around 20,000 liters tends to be some of the higher or larger systems in the pharmaceutical industry. So there are larger out there, but that's a good baseline for, kind of the large scale stainless facility. These by far have the lowest cost of goods sold for a single product. If you have one that just needs to turn over quickly, like a blockbuster type drug. There's really no process performance limitations that you would see in single use. You've got that overlay pressure capability that helps you with your mass transfer. You've got the stainless steel in direct contact with your fluid media, which removes any kind of heat transfer concerns. So really no performance limitations there. They also have, unfortunately, one of the highest capital costs in the grouping here. That's mainly due to the piping and size of the stainless steel reactors and that supporting equipment for them. SIP, CIP skids to go along with just the bioreactors, which you can cut out on the single-use side, especially if you wrap into just the facility utility equipment as well. You can get rid of your steam generator entirely for a lot of the single-use case facilities. You also have a long time to market, mainly due to the complexity and again, kind of the additional equipment necessary to support the stainless steel bioreactors. And the changeover between product to product in that facility is really difficult and has some risks from a quality or FDA approval standpoint. So when you're going to design your facility, whether it's a retrofit, whether it's a brand new facility, looking at forward into the future, there's a couple things that you want to be thinking about. And, all of these are really going to lead into your final decision of, what's correct for you or for your company. So on the process side, we're really looking at, scale and output, how much drug product do you need to get out of that facility, just raw kilograms of material. We'll talk a little bit more about where these land later on. So we'll just kind of point out the factors for now. The yield of the equipment in the process. So again, if you're high titer processes, that might push you more towards one side. And if you're low titer and you really need high volume to get the same amount of product out, that could push you in another way. You also want to take a look at your process requirements, specifically in the pharmaceutical industry. We're really looking at mass transfer. That's oxygen transfer rate to the cells, or the uptake rate. Mixing performance in the system, heat transfer, and just making sure that you have the right additions and chemical effects going on. Another concern that might come around is cycle time. So that's turnaround time between a batch to batch. You can do a lot of things with this in single use. If you have, for instance, a seed train made up of single use feeding multiple stainless steel production reactors, you can turn that seed train over significantly quicker than a stainless steel one. So you might end up being able to seed, let's say 3 production reactors with a single use train versus maybe only 2 with a stainless steel train because of those SIP, CIP, and cleaning qualification, quality checks. Looking at, the product or the process status, where is it in the phases of acceptance? Is it preclinical, is it clinical, or is it a licensed drug going into, GMP production? That can really have an impact on what kind of facility you design, just based on, the batch sizes. Typically preclinical and clinical trials are much smaller versus kind of a, full scale production facility that's just looking to pump out product. Another consideration on the process side would be, what facility size you have available. Obviously, clean room space is expensive, so the footprint as well as the clean room height could dictate what kind of equipment you can fit in there, or how much production volume, whether that's 4 by 6K or 6 by 2K or whatever you want to set up in there. Finally, looking at the business cases. So end of the day, the number one is going to be cost of goods sold. From a business standpoint, that's really going to be your be all end all, is to make sure you're getting product out of there in the most efficient way possible. This is going to include everything from labor, raw materials, disposables, as well as overhead costs and depreciation of running it. Finally, you want to think about what kind of flexibility do you need in the facility. Again, a lot of times you might just need to crank out one product. In that case, that might be pushing you more towards stainless steel. But if you need that flexibility of turning over multiple different products in the same facility, throughout the year, you might want to start looking at a single-use approach, especially looking in the future, whether you want to be, changing out different products if new things come down the pipeline, as well as making sure you have the ability to, expand. Maybe it's a scale out, even rather than a scale up. Single use, that's definitely been a popular approach among some of our customers. You also want to have an understanding on your capital costs. Like I pointed out before, stainless steel equipment is more expensive from a capital aspect than the single use would be. So this makes it very appealing to a lot of smaller companies or startups, or companies, just starting out in the biopharmaceutical industry. They can, get in with a much lower entry capital. Another consideration is going to be schedule. If you really need to get product out quickly, you need to get your facility started up, within a year, maybe within 18 months. You're really going to be wanting to look at the single-use side of things, rather than stainless steel, which stainless steel facility could take anywhere from 2.5 to 5 years to start up and start producing product, depending on the scale. And finally, you want to look at the supply chain aspect of this and really make sure that your consumables are coming in consistently. It's really important to have redundancy in your supply chain wherever you can, whether that's manufacturers, suppliers of sterile connectors or tubing. Depending on how you have things set up, you might be able to swap in and out different types of tubing if there is a shortage at some point. So if we take a look at cost of goods sold and a couple different layouts here, we're looking at a MAB facility or a MAB process, and each bioreactor will assume is running 20 batches per year over a 15-year depreciation, 75% overall yield from the process throughout the downstream purification. When you do these cost of goods, I have an example up here of one that we've run for someone, but it's really going to be dependent on each company, each facility, and each product that you're trying to get through there. So this is not something you can really just take as fact. You really need to do it for yourself, or work with someone to get these numbers figured out. So if we look at the examples here, we have a 6x2K single-use facility, a 2x6K single-use facility, and a 4x6K single-use facility. So looking at those really much higher production and output volumes here. So you'll see we held the titer and the kilograms per year of product the same between the 6x2 and 2x6. And then if you look at kind of the economies of scale, we doubled the total production capabilities on the right side. The main reason for that is if you look at the 6x2K, the footprint taken up in a facility, it's actually even larger than what you would need for a 4x6K setup in that same space. So you'll see the raw material costs are going to stay the same as far as per gram of product produced. You'll need the same amount of media, the same components to produce that 1 single gram of product. So that's just something to keep in mind as you're looking across the columns, is that this is all on a per gram of product basis, not just per batch or per liter of facility. So the disposables and consumables, you'll see with the 6x2K, as you can imagine, you're going to be going through 6 bags for every 12,000 liters produced versus just 2 for a 6,000 liter facility. So there's some benefits there. Capital depreciation is going to be very similar across these different facility layouts. And that's really looking at kind of the overall building, all of your utility piping. The labor costs, you also have to keep in mind, how many people does it take to run, one system. So, if you're running 6 systems at a time, you're going to have, the supporting personnel to do that, versus if you're only running 2, it's going to take fewer people in the facility to do that. So you see at the bottom, we totaled them up. I'm just looking at, again, this single example is going to be, $100 per gram, for a 6x2 facility, about $80 per gram on the 2x6,000. And then, if you really need to crank product through, have those larger production volumes, it actually cuts it down to about $61 per gram. So you can really see that, economy of scale. And kind of the sweet spot for this, we'll call it mid-scale manufacturing when you think about the large 100, 200,000 production volume stainless steel systems that have been built in the past. So this is just some examples of how we look at customer's product, what they want to do, looking at their titers, and looking at the market size, basically how much do they need. And from that information, we're able to, look at a recommendation for what fits their needs best. Is it stainless steel? Is it single use? Is it either or maybe a mix, a hybrid approach of some kind? So one of the product examples here would be a protein therapeutic. So This has a product titer of 1 gram per liter, so pretty low potency. But the market size here was assumed to be very large, and the product value was medium to high. So from this, we were able to decide that they're really going to need a lot of production volume because of that low titer and high demand. So for that, it's really stainless steel fermentation, every day of the week. It's just very clear. If you need to crank one product through a facility, stainless steel is going to come out ahead on cost of goods over the long term. But now if we're looking at maybe a protein therapeutic with a little bit higher potency coming from the 1 gram per liter, and then still a large market size, but in this case maybe you only really need about 10,000 liters per run. So in this case, you could really get away with running maybe 5 or 10 single-use fermentation systems versus maybe a single stainless steel fermenter. Now it's really going to come down to looking at what does the company or the customer want to do in the long term. Is it just going to be that single product? Then you might still want to go to stainless steel. Or maybe if in the future they see, okay, we want to be able to have the flexibility if we do have another product to switch this facility over easily, or maybe alternate batches during the year. Then maybe you're going to start looking more towards that single-use side for the flexibility. If we look at that higher titer trend, we're seeing 4 to 5 grams per liter, very high potency drug, and we're seeing those smaller batch sizes, kind of with that personalized medicine approach, or just just the demand of every product. Every therapeutic out there is not going to be a blockbuster, so maybe you do need to make smaller batches of a single product to satisfy the demand on the market. So in this case, we're looking at fermentation volumes 1 to 4,000 liters, and this is really going to be best served by single-use fermentation. If you're only going to be running a few batches a year, and they're very high potency product and high titer, you can get away with the single-use side, get the benefits of quick turnovers and low cost of goods out of the fermenter, while still maintaining that flexibility if you then want to use that capacity for something else throughout the year or in the future. We won't go through all of them. You can kind of start to see the trend here of if you have high titers, if you have low or high demand, that's going to drive you one way versus the other. I would say that one other one we want to touch on here is maybe the lost my place. So maybe the small molecules, looking at that, really low titer, low potency drugs, but still with a large market size. That again, is pushing you towards that stainless steel fermentation because of that low titer, but still the high demand requirement. So just some cautions on single use and stainless steel as you're looking through your facility design, weighing the pros and cons of each. Single use is still a fairly new technology in the industry and growing. I mean, there's new technologies coming out every year, trying to push the industry forward or offer more analytical tech to the single use side of things. But with new, you can have a lot of great successes with that, but there is some amount of risk added on for anything that's new and unproven. Stainless steel is certainly still here to stay. Again, really looking at those large batch sizes, single product facilities, you really can't beat the cost of goods on stainless steel and the efficiency there. There's also, especially on the fermentation side of things, concerns with performance. So there's definitely a limit on stainless steel of how large you can go with fermentation. For instance, like on Pichia or high density E. coli, you might be looking at 10,000 liters as your absolute max before the cooling becomes too difficult to maintain. On the single use side of things, you've got that film material. It's a great sterile barrier. Unfortunately, it's also a good insulator. So you'll be performance limited a lot quicker on the single use side of things than you would be on stainless steel. You also want to ensure that your single-use equipment selections will meet your process needs, which is kind of what I was touching on there with the performance, especially as you start looking at larger scales. As you'll know from benchtop reactions, it's pretty easy to get things done at a small scale. You might run into other problems actually working at that small of a scale, but once you start getting larger and larger and larger, you really want to make sure that your equipment is doing what it needs to keep those cells happy and producing at their optimal rates. Another takeaway is that customized solutions generally do have a higher capital cost, but there's potential value in process transfer and scale up. If you're coming from a 20K stainless steel reactor and you want to bring it scale down or transfer over into single use for whatever reason, moving facilities, different flexibilities. It makes it a lot easier if that system is geometrically similar, as well as being able to provide that same power input, that same gas flow that you're used to seeing over in stainless steel. The customized solutions also will, as I touched on before, help you raise your titers and your yields throughout the process. Customizing the equipment to the cell line, to the process, is always going to yield higher results than trying to make exceptions or change things around on your process just to meet whatever your equipment is that you have in-house. There's also a lot of benefits to facility integration when you start looking at customized solutions. That could be everything from automation flexibility to placement of the systems, or as simple as you just want the doors to open a different way when you're setting up your facility, which doesn't sound that hard, but if you're buying something off a catalog, it might have a left-hand door, and you're gonna have to build your facility around that rather than I want to maintain space, create better flows of my materials. Okay, maybe I want them opening in towards each other to save space. There's also some benefits to regulatory compliance with the customized solutions. Again, if you're coming from a different reactor or coming from a different system, if you're bringing it over and you can show the equivalency of the products, or sorry, of the equipment, it makes it a lot easier from a regulatory compliance perspective as well. And finally, the operations and maintenance of single-use systems just in general is much, much easier than the stainless steel systems. Your product contact surfaces are obviously all disposable, so you don't have to worry about cleanability or surface finishes there. You're also going to have many, many fewer valves and pumps because you don't have the SIP, the steam in place, or the CIP clean in place cycles. So much simpler systems overall, which should lead to easier maintenance and more longevity for the system as a whole. So now we'll take a look at a couple case studies here. Full stainless steel designs have remained largely the same throughout the last couple of decades. So I'm not going to spend too much time there, as a lot of the facilities of the future are really starting to look at single-use technologies, especially around hybrid facilities, or just even more recently, full single-use designs, really embracing the technology. When we look at hybrid facilities, a lot of times we'll see the media prep, buffer prep, and the downstream facilities still stay stainless steel, while the seed reactors and potentially even the production reactors are going to be in the single-use mode. And finally, we have full single-use facilities. When you're looking at full single-use facilities, some things to keep in mind, just smaller items. Single-use tubing becomes a big deal if you're running between different reactors, if you're running over to your harvest skids or your downstream preps. You don't have the same ease of stainless steel transfer lines that get cleaned out in between, so you can end up with a lot of tubing runs if you're not careful, which can cause a lot of hassle for operators. You also want to be really cognizant of your material flows, as well as loading of the single-use consumables into the holders. With stainless steel, the reactors are in place, and for the most part, they're just operating in place. With single-use equipment, there's a lot more interaction with the equipment and flow of materials in through the facility that wouldn't have been there before. Kind of with those, expanded consumables, you really want to pay attention to warehousing space. Single-use facilities definitely require more warehouse capability than the stainless steel equivalent, because instead of just media components coming in, you now have media and the consumable, we call them DC, disposable containers, but the single-use bags coming in. With those, a lot of this is focused on single-use, so the consumable side. You also want to be able to pay attention to the waste management. You want to have a plan for the disposal or recycling of the single-use materials that are flowing through the facility. So this was a conceptual design for a hybrid facility. You'll see on the left side here, let me try to move my bar here. So we have the single-use preparation in the back side here. I'm not sure if you guys can see my cursor or not, but it's the back left large stainless steel tank. So that's going to be used for bulk media and buffer preparation. We have platform set up. On the right side is going to be your upstream processing. This is in the shape of kind of a ballroom facility type layout. And then on the center stage is going to be all of your downstream cooling, purification. It's a little difficult to see, but if you look on the bottom view here, side view, you'll see all the processing equipment, or a lot of it for the downstream and even the upstream, is actually underneath the platform. So this unlocks a cool space-saving consideration with the horizontal buffer hold. This is a large volume solution hold in 4,000 liters that ABEC has designed. And putting that up on top of the platform has a couple advantages. Obviously, the main one being space savings. You don't have to move around 1,000-liter totes around the floor. You don't have, or just sitting in place, taking up a lot of extra floor space to work around. You also get the benefit of the media being able to pass through the floor, clean up a lot of your tubing runs, and feed down from a headspace perspective, to the point with if you size your tubing correctly, you can actually get away with running your systems without pumps. 1-inch tubing in this case, commonly available in single use, is able to get up to 60 liters per minute flow out of these horizontal hold tanks, depending on the headspace pressure. So you can handle a lot of your liquid movement concerns in a speedy fashion without pumps in a lot of cases. So you'll see, we have a lot of the reactors facing out, again, to facilitate the loading of the disposable containers, the bags. We also have, open flow paths here for, consumables, media, and whatever else you need to move through the facility. So this facility was designed to produce, 2 tons of monoclonal antibody in only 1,000 square meter facility. So this was really showing how compact you can make single use, in this case, hybrid facilities to achieve, process requirements and production requirements in, kind of that compact footprint that you couldn't get in stainless steel. So looking at this particular one, one thing to mention is this is assumed a seed train, 1 to 2, depending on how many reactors you have, whether it's 2 to 6. In this case, they're 4,000-liter reactors operating in a fed batch mode. We have a couple facilities coming up that start looking at, higher, tighter fed batch, as well as perfusion. So this facility here, you may actually be familiar with if you follow ISP closely, won the Facility of the Year award. This is Wuxi Biologics in Ireland. It's a 48,000-liter production volume facility running 12 by 4,000-liter single-use bioreactors. This is an example of that hybrid single-use upstream and stainless steel downstream approach that we talked about. it kind of looks a lot like that concept that we had done up front. You'll see the media prep in the model on the left side there, large volume, feeding into the upstream suite. In the center section, we have some pictures of that on the right side here, all platform driven around to help with the loading aspect of the single-use materials, as well as the operations and keeping everything clean on the floor there. So the next case study we'll look at is a large-scale single-use facility running monoclonal antibodies. This one's different because they're actually running N-1 perfusion in their seed reactions, feeding into 6,000 liter single-use reactors from the seed. So this is important because with perfusion, you're going to have to be running a lot more media in and out of the suite. This is where the kind of second floor approach with the platform for media storage really shines. You'd be able to provide your system with the media flows required without, with or without pumping, but also just makes it easy to access, dropping down through the platform. That cleans up the facility, cleans up a lot of your flow paths, and has a lot of advantages that way. So like I said, this was 10 by 6,000 liter facility. So this is a 60,000 liter production volume facility, which can rival, what you'd see in a lot of stainless steel ones. The idea behind this facility was, really to be able to crank through one product, but without looking to the future of still having that flexibility to run multiple products, depending on how the pipeline works out. And maybe as this current product that was driving the demand matures, maybe it will require even larger facilities. So maybe they'll move that one to stainless steel, still have the flexibility in this existing suite. Some of the supporting equipment along with this, operating at these really large volume single use is going to be supporting equipment of 5,000 liter and 7,000 liter general mixers. This is for downstream pooling as well as their harvest steps. They're also going to take a single-use approach to the downstream side of things. So they're running a completely single-use facility in this case. So one consideration they had for their final purification step, they're using a single-use TFF system, but they also wanted to have the ability to get really low hold-up volumes and turn down mixing. So with that, instead of using kind of a square hold bag, they've looked to ABEC to design a cone bottom reactor that'll allow them to get that really low turn down, very similar to a tulip tank in stainless steel. So just to summarize, what you're going to really be considering when you're designing your new facility is the number of products you want to get through, what kind of process technology you're looking at. Is it mammalian? That opens up a lot more doors in single use. If it's microbial, you really want to pay attention to what kind of performance requirements you have. Where the product is in the pipeline. Is it commercial? Is it licensed products? Are you producing for clinical or just full production? Also looking at obviously the quantity of required drug as well as dosing levels of that drug for the patient population. You also need to know what your process yield or your titer is going to be coming out of the facility or coming out of the upstream side of things. That's going to have a huge impact on not only what size you use on the upstream side, but also how large your downstream suite is going to need to be and whether single use is going to be viable on the downstream side. One thing I might not have mentioned throughout the presentation is that if you're running much higher volumes, it's kind of similar to the upstream stainless steel reactors. Stainless does the large scale a lot better on the downstream side. So you can make TFF systems, accounting for 60, 80 square meters, whereas in single use, we're limited at 40 square meters. And finally, you want to take a look at the geography, the location. This is everything from the available workforce, how much land Is there infrastructure around to support the recycling or disposable of your single-use consumables? And kind of along with that is, what the local regulatory authorities are and what kind of requirements they have for the facility and, the products going through there. So all of that's feeding into your decision factors, cost of goods, your flexibility, how fast do you need to get your time to market, capital costs, of course, and compliance and technical feasibility. So if we sum that all up, again, just to fully recap, when stainless steel preferred, when you have that single product that you need to get out in large volumes, or if the product has a low titer, low yield, and you need that large volume just to get a certain amount of drug product. If you're looking at mammalian or large scale microbial, you want to be looking at stainless steel. Large scale mammalian. If you have a commercial or a licensed product, stainless steel is definitely a preferable option because of that repeatability and the well-known nature in the industry. What I talked on before about the higher production quantities and lower yield. And finally, if you have the available land and infrastructure for the larger stainless steel facility, could also be a preferred choice. When you're looking at single use, that's going to be preferred if you have those multiple product facilities. It's especially lucrative and for CDMO organizations because they're going to be running different customers through there. It makes the changeover and quality aspect of that much easier if you're disposing of your product contact surface every single time. If you're looking at mammalian or kind of smaller scale microbial up to 1,000 liters, single use could be the choice for you. If you have mixed clinical and commercial manufacturing, because of that ease of product changeover and the small scale performance of single use, it makes the clinical manufacturing side of things very lucrative because of that low capital cost to start it up and the reduced facility utilities that you need. You don't need a steam generator. You can plug most single use equipment into just a standard laboratory space with electrical power. If you have lower production quantities in general, single use could be a choice for you. If you have higher yields, and finally, if you have limited space, whether that's because you're retrofitting or you just don't have the land to build a very large facility, single use allows you to get a lot of production capacity into a much smaller footprint than you would get in stainless steel. So at this point, I'd like to open it up for a Q&A if anyone had questions throughout or anything to add at the end here.
Thank you, Colton. So we haven't got any questions on the chat yet, but please feel free to post them or unmute yourself and ask Colton directly. There's no silly question, only all good questions. So please don't be shy. Just while we're waiting, and if everyone's thinking about a question, just to let everyone know that this session has been recorded and it will be saved onto the ISPE Singapore YouTube page. So if you can search for that, there are lots of webinars, Technical Tuesday sessions, and other content which you can watch from there as well. And you can see and meet up with colleagues from ACI Sciences in our upcoming annual conference and exhibition from the 24th and 25th of August at Suntec Singapore. So they will be there in person to answer any questions and to view their exhibits. Does anyone have a question? We've got just a few minutes. Must be that you've covered everything, Colton.
You know what? There was a lot of information there, so maybe people need some time to digest.
Definitely a lot to take in. And if anyone has any questions for after the session and wants to ask Colton or any of the team from ACI or ABEC, please do get into contact with us and we'll forward the question on.
Absolutely. Happy to help wherever I can.
Thank you. Does anyone have anything? I know it's a Monday morning. It's the start of a work week for everyone, and they've probably all got to get on to places. So if there are no questions, we'd like to finish a few minutes early. I'd like to thank Colton for spending the Sunday evening with us and for joining us and for a very comprehensive presentation. And also for the ACI colleagues in Asia for arranging your participation. So if there's no other questions, this is your last chance. If anyone has a burning inquiry or comment or suggestion. We have one from PD. Is it common to use a similar plant for preclinical and clinical lots?
It's definitely not uncommon. We've certainly seen a lot of customers use, the same CMO to produce their preclinical and clinical batches. Hope that helps a little bit. But
does that answer your question, PD? Yes, thank you. Mm-hmm. Does anyone have one last question? Looks like we're good, Colton.
All right. Thanks again for having me.
Yeah, so thank you very much. We'll leave you to carry on with your evening, what there is of it, and have a good week. And to everyone, thank you for joining us this morning. And we look forward to seeing you at our show in Singapore and for further future webinars. Thank you very much, everyone.
Take care.